Hello class, today we are going to talk about similar figures. Right? This video is going to be pretty much review. You've talked about similar figures for a couple of years now in school, so we're going to go into a little bit more detail, a little bit more technical stuff, but it's still pretty familiar stuff. Right? So here we have two similar figures. The definition you got probably when you were in earlier grades is they are the same shape and different size. Right? So you see how these are the same shape, just one's bigger than the other. We're going to define it slightly different. We're going to say that similar figures are dilations of each other. All right. So you can see that the red and blue figures here, they are dilated. If you'll recall, when we talked about transformations, we said that they dilate from a center of dilation. So here you can see the rays of dilation go from a center over here through the corresponding vertices, right? And let's get rid of those because they're in the way. And that is kind of how we're going to name this, all right? We are going to, right now, real quickly, we're going to set up a similarity statement, which isn't really a big deal. It's just saying that this figure is similar to that figure. So figure ABCDE is similar, this little squiggle right there, that means similar, is similar to figure ZYXWV. Now notice the order, I didn't go in order, that went backwards, right? The reason for that, again, it comes back for this is a dilation, right? These corresponding vertices have to go in the same order, just like we did with the congruent statements, all right? So what this is lets us know that angle A matches up and corresponds to angle Z. Angle B corresponds to angle Y, C corresponds to X, D corresponds to W, E corresponds to V. All right? Has to go in that same order. This is also good because when they're in that order, we know which ones correspond to each other, and that's very, very important. Because if you'll notice, those corresponding angles are congruent to each other. Right? Each of those pairs of corresponding angles are congruent. Because remember, when we did dilation, it didn't change the shape, it didn't change the angles, it just changes the sides. So, corresponding angles of similar figures are congruent to each other. Very important there. Now, the sides, of course, the sides are not congruent. The sides are all different, right? And the thing is, remember we had it's a dilation, right? And when we talked about dilations before, we said that they change by a scale factor. And we still have that same scale factor. We can set it up new over old. With this similarity statement, the new one is the second one. All right? So it's new over old. So we can set them up like this. 6 to 12, 4 to 8, 3 to 6, 4.5 to 9, 5 to 10. Right? And those all equal, right? You can see very clearly those are all the same thing. They all equal 1/2. Right? And that is your scale factor, that's K. Right, so corresponding sides of similar figures are, we're going to say that they are proportional. They all have the same scale factor. Right, and so that's similar figures. We're going to look at it real quickly. So similar figures have corresponding angles that are congruent, corresponding sides that are proportional. Let's take a look at this real quickly. Which figure is similar to EFGH? So here we have a rectangle EFGH, and we've got two other rectangles. We want to know which one is similar to this blue one here. Now notice, they're all rectangles, right? So the corresponding angles are congruent in both of these, right? Both of these, they've all got right angles, so all of the corresponding angles are congruent. Does that make them similar? Is that enough? Right? Well, let's take a look. We also said that the sides had to be proportional. So let's take a look at that. Let's just look at ABCD. So here, 1 to 3 and 2 to 9. Well, do those ratios work? Is 1/3 the same as 2/9? No, that doesn't work. So the angles were the same, but the sides didn't match up. Okay, well, let's look at the other one. So here we go. Let's see. We have 2 to 3 and 6 to 9. Are those the same? 2/3, 6/9. Yeah, those are the same thing. That works. And so there it is. It works. Now, when we have proportions, remember another way we can check that when we have these two things is that the cross products equal. So this little butterfly thing, right? We can do like that. 2 times 9 equals 3 times 6. Both equal 18. So that also checks it. You'll see this one up there. We have 1 times 9 and 2 times 3. And 6 does not equal 9. So again, no good. All right, so you can check it either way. And this is very useful when we're solving for missing things. So which one works? Which one is similar to EFGH? Well, that's this one here, KJML. Notice that's not alphabetical order here. We've got to match it up. E goes to K, F goes with J, G goes with M, H goes with L. You got to keep those matched up in the same order there. So, was it good enough that all of the angles matched up, the corresponding angles were congruent? No. You got to have proportional sides as well. The sides aren't proportional, it's no good. Also, remember we said that it's a dilation, right? So if you'll notice, if I take this and I keep the aspect ratio the same, and I just dilate it out, it doesn't match up with EFGH, does it? Doesn't match up, it's no good. It's not a dilation. But if I take the other one and get that in position there, right? Just dilate it out, keep that aspect ratio the same, notice it matches up. So this is a dilation, whereas ABCD is not. Alright, so let's take a look at this one. Which figures are similar? Well, if you notice, all of them have congruent sides there. All of the sides are proportional, aren't they? This is 4 over 5, 4 over 5. That's going to work. 4/5 equals 4/5. 5 over 10, 5 over 10. 5/10 equals 5/10. That's both a half, right? But are they similar? No. Quite clearly, NOPQ is not similar to RSTU. Right? The angles don't match up. You have to have those congruent angles. So, having proportional sides, is that enough? Yeah, no, clearly not. We have to have congruent angles. All right, so RSTU is similar, remember that little squiggle is similar to YVWX. All right. They have to have those congruent angles and also proportional sides. You can't just have one. All right. So, has to have congruent angles, has to have proportional sides. Remember, if they are proportional, the cross products will work. The ratios will have equivalent fractions, equivalent ratios. All right. Also, real quickly, are congruent figures proportional? If I take this and I dilated it so that it matches, there we go. Are these congruent shapes, there we go. These congruent shapes similar? Yes, they are actually. Congruent figures are similar to each other. They will just have a scale factor of 1. But they are still similar because you can use a scale factor to get from one to the other. That's why the congruent symbol has this little squiggle in it, right? That equal and similar. These are just similar, not equal, not congruent. So remember that means similar. Make sure you have them in the same order. Corresponding angles will be congruent. Corresponding sides will be proportional because these are just dilation with a scale factor of something. All right. Hope you found that useful. I will see you in the next video.